Hi Year 9s, sequences. I've noticed on my maths you're still struggling a little bit with them, and I would love to just give you a bit of help, so I've written a few things down for you. You need to start with a tiny bit of algebra on sequences. You need to get your head around using letters that stand for numbers, and we're using the letter N a lot because natural numbers, whole numbers, show the position of a part of the sequence. The positions can only be whole numbers. You can either be position 1, position 2, position 3, and so on. And this sequence here, you're really familiar with. It's the 5 times table, 5, 10, 15, 20, 25, and so on. And why is it, for instance, that n is 4 here? Because look, 5 times 4, 5 lots of the fourth position, bearing in mind that 5n means 5 times n, 5 lots of n. Well, fourth position, 5 times 4 gives you 20. Third position, 5 times 3 gives you 15. That's how the logic behind a sequence, behind an algebraic sequence works. Okay, and then of course you can do that for the 3 times table, which unsurprisingly is 3n, 3 times the position. So 3 times the fourth position, 3 times 4, 12, there's your number. 3 times 5, the fifth position, 1, 2, 3, 4, 5, 15. Okay? What if I took a sequence that's a little, sorry about the camera work, a little bit more complicated, like this one here. Every time, look at the numbers compared to the 6, the 5, the 9, the 8. Every time my number is a little bit smaller than the 3 times table. In fact, it's 1 less than the 3 times table. It's an 11 instead of a 12. So we call this 3n minus 1. 3n would be the 3 times table. Take away 1 means just 1 less. And equally here, look at these. The 4 times table goes 4 plus 3 is 7. Second number in the 4 times table, 8 plus 3 is 11. Third number, 4 times 3 is 12, plus another 3 is 15, and so on. That's how these rules for sequences work. Now, that's quite basic here. What if I have it the other way around? What if I have a sequence given, 6, 11, 16, 21, 26, and I want to know what the rule is? Well, first I'm looking at how does it go up? Oh, look, it goes up in 5s every single time. Okay, I know a sequence that goes up in 5s. The 5 times table, 5, 10, 15, 20, 25. And the sequence I've been given to start with is 1 more than the 5 times table. Here's the 5 times table, there's the sequence. Right, there's the rule. Let me show you that again. There's my sequence, 2, 6, 10, 14. I figure it goes up in 4s. So it's a bit like the 4 times table, which is 4n, or 4, 8, 12, 16. And if I look at my 4 times table, that one is 2 smaller. That one is 2 less. That one is 2 less. And that one is 2 less. Right? 4 times table, take 2. There's your sequence. One other important thing you can do with sequences is you can ask, not just what's the next number in the sequence, by the way we call them terms, what's the next term in the sequence? What if I wanted to know something like the 80th term in the sequence? Well, you can use the rule, I've just done it for this rule that we've had here, 5n plus 1. If I want to know which is the 80th number in the sequence, the 80th term, I just replace n, which notates the position number, by 80. 5 times 80 is 400, add 1, 401. Do that for the other sequence, the 4n minus 2. What's the 80th number in that sequence? I do 4n minus 2, so 4 times 80 minus 2. 4 times 80 is 320, take 2, 318. Now, for your homework, or classwork should I say, I've prepared a few questions. Don't worry about the image there. It looks like this. I will send you a photo of those and show my homework, and I would need you, hang on, there's find the 90th term, there's your task. Okay, you can either freeze the screen now or call up the photo that I'm sending you with it. Good luck, bye.